Hello and welcome to Sudokanar. We are here to solve this skyscraper Sudoku by Serbian author Zoran Tanasic. This puzzle was featured in the latest WPF Sudoku Grand Prix. It was worth 49 points, and my feeling is that it was a little undervalued as it was a rather difficult puzzle, not impossible by any means, but it really needed some time to work it out. So the rule is it's actually a mashup between the usual rules of Sudoku and the usual rules of skyscrapers, which is that every number in the grid is interpreted as the height of some building, and higher buildings they block from view the lower buildings. And the numbers outside the grid are the numbers of buildings that are visible from this side. So here we must be able to see seven buildings. What's happening here? So we must be able to see seven buildings from this side. Here we must see only two buildings, which means that building 9 will probably hide a lot of the digits. So where to start? We are seeing here that we don't have digit 1, but we have an empty clue, which means that 9 can only be here, because 9 would come with a clue of 1. So that is where 9 is. And actually, it's usually very useful to locate the 9s. So we know that now that must be a 9 somewhere here, but we don't have ones here, so 9 can only be here. And you can see that this 2 clue will always be fulfilled, and it was actually useless. So now where do we look? We should try to locate the other 9s. So where does 9 go in here? Because of this 3, 9 can't be in here. Here the clue would be 1, here the clue would be 2. So 9 is in here. But with a 3, 9 can't be here, because then with a 9 here, the clue would be 2. Same here. So 9 must be here. And this is and this clue is fulfilled whatever goes into this cell. And this 2 is not useless because we used it to secure the position of 9 in here. Now we know that 9 must be somewhere in here. Because of this 5, 9 can't be here. So 9 will be somewhere in here. Now, what about this region? So 9 is not in here. Because of this 4, 9 can't be in here. Because of those clues, 9 can't be in here. And 9 is not here because of that. So 9 is here. And now, in this area, by the rules of Sudoku, 9 is in none of those cells. 9 is not here because of this 3, so 9 is here. And there will be a 9 somewhere here. And on this row, 9 can now only be here. And I think that's it for digit 9. So this will have to be disambiguated later. And I think I remember that there will only be disambiguated at the very end of the soul. So what do we see? Well, this 6 clue is interesting, because with this 6, the highest number of buildings that we can see is actually 6, and it requires that 7 and 8 be seen. 7 somewhere in here, 8 somewhere more on the left. And that it requires that we see also those buildings. So we see this one will be bigger. Then we'll see the 6, then we'll see the 7, the 8, and the 9. So this is smaller than 6, and it's not one of those, and it's not 1. So this is 2 or 4, and this is smaller than that. So this is from 1 to 3. And then we get a 7 somewhere and 8 somewhere. We can see that 8 is not here, 8 is not here, 8 can't be here because of this 7. With 8 here, we would see at most 4 buildings. So 8 must be somewhere in here. And 7 appears before, it should be here. It could not be here. We would see at most 5 buildings. It can still be here. So 7 is here or here. But actually 8 wouldn't work here because in this column we would see the 9, we could see the 8, and we could see this building, and 2 would be false here. So 8 is actually here, 7 comes before, not here, not here, so 7 is here. And now this building must be bigger than all of those without being 8. There are 6 buildings here, so the only value is 7, and 8 goes there. So now this 3 is fulfilled, this 2 is fulfilled, and this 3 will be fulfilled as soon as we put something here that is bigger than 3, which is 4, 5, or 6. So this 3 is now fulfilled. This 3 will be fulfilled as long as this is bigger than that. So that we see only 3 buildings, this one, the 8 and the 9. So this must be bigger than that, so that is not a 2. This is also from 4, 5, 6. And 2 will either be here or here. Now this 4 requires that 8 be seen. 8 won't be here because of this 8, it won't be here because of this clue, it won't be here because of this clue, so 8 has to be here. And now this is fulfilled. Something of interest here is that neither 7 nor 8 appears here, so they must both be in here. And we can see that because of those 4 clues, 8 can't appear in any of those cells. And the reason is that, well, with 8 here, we can see at most 3 buildings, same here. So 8 is in here, and 7 will be either here or there, but 7 here doesn't work, because 7 hides this one from view. With the 7 here, we would only see this, the 7, and the 9, which would be 3. So 7 has to be here. And to see 4 buildings here, it means that we must see the building 8 in here, which can only go next to the 2. And now this 4 will be fulfilled. And this one will be, this 4 here will be fulfilled as long as this is an ascending sequence, so that this is smaller than that. So this must be from 1 to 4. And this from 2, 3, 4, 5, but bigger. So this is basically done. This is absolutely done. This is done. This will work as long as this 3 will work as long as this is not a 6. Now this 3 here means that this building will hide all of them. So it has to be the 7. So this will be valid as long as this is smaller than that. And this, can this be a 5? Yes, it can be any digit at this point. Where is the next place to look? This 5. We have 8 and 9, which will be seen, and we need to see all 3 digits here, all 3 buildings, so those must be ascending. I'm tempted to use a thermometer to show that, to picture that. Oh, maybe it's a good idea, actually, to put a thermo here. Yes, that's a really good idea, actually. And now I should use this more often, like this, for example. No, Is it true? Oh, I did something the wrong way in my pencil marking. This is never a 2. This has to be lower than that. So 2 is one of those two places, and this is from 4, 5, 6. There again, a typical Canard mistake, typical Canard blunder. This 3 will always be fulfilled, so it seems. We will see this, the 7, and the 9. 8 is somewhere in here. What about 8 in this area? With those 8s, we know there's an 8 in here, and to see 4 buildings, we must have the 8 in this position. Here, the clue would be 3, here it would be 1, and actually here is another possibility. So now this 4 requires that we have a thermometer in here, ascending digits, and 7 has to be somewhere in here. Eight, well, just by the rules of Sudoku, this is 8, so that this 2 clue is fulfilled anyway. And actually, I've located all the 8s in the grid. So what do we know about this? Minimum 1, 2, 3, well, a lot can still happen at this point. With those 7s, I can place a 7 here, and now this 3 is satisfied. I need to put a 7 somewhere in here. 7 here wouldn't work, because then we would see 7, 9, and this building, so 2 wouldn't be correct. 7 here doesn't work, 7 here seems to work. Oh, actually, 7 here does work as well. So there is 7 in here, 7 here. 7 here wouldn't work, because then we would see 3 buildings here at most. This 7, 8, 9, that would make 6. So 7 here doesn't work. Actually, in this column, 7 can only be here, which places 7 there and 7 there. Do we have all 7s? We do. With those 5s, this is a 5. This is not 5, and by the rules of Sudoku, this is 5. This can never be a 4 now. So we need 1, 2, 4, or 6, but 4 here wouldn't work. We would see at most 5 buildings. So this is 1 or 2, this is 4 or 6. 5 is not in here, 5 is not in here. 5 here would work, and 5 is not in here, so just by the rules of Sudoku, 5 is here. We still need 1, 2, 3, and 4. This here is bigger than that. Six now is somewhere on this row, and because of the ascending property, this is the only place. 1, 2, 3, 4. Actually, 3 is nowhere in those cells, so 3 is here. This is now fulfilled. This will always be fulfilled at this point. We still need 1, 2, and 4 in those spaces. This 5 is fulfilled now. We need a 6 somewhere in here. Any place will work. 2, 4, 6 in here. This is ascending. So this is from 2, 4, and on this row now 6 can only be here. So that this is 4, this is 6. And this is 2 or 4. On this row 3 has to be here. And this is the 1, so that's a 2, that's a 1, that's a 3. And that's a 4. A 2, a 4, and a 2, and a 4. So a lot is happening. I don't remember doing those things in this order, but then there has to be a multitude of, how to put it, solving paths. With the threes, there is a 3 in here. Now, where do we look? This must be ascending. In this column, we still need the 5 somewhere. 5 can only be here. And those are 1 and 4. What about this? So we see the 3, we'll see the 9. So this could never be a 4, because then we would see 3 buildings plus the 9, and actually 4 is not available. So this has to be smaller than 3, because it's necessarily smaller than 3. So we see the 3, the 5, and those are from 1, 2, and 9, and actually any combination will satisfy this 3. This 4 must be fulfilled. If this is bigger than that, we are left with 2, 4, 6 in here. So this is bigger, this has to be 4 or 6, and this is 2 or 4. 6 here will never work, because 8 is hidden behind the 9, so with 6 we will never satisfy this. So the 6 is actually here. This is 2 or 4. We must see a 6 somewhere in here. But here it would work. We would see this, the 6, the 7, and the 9. Here we need a 3 and a 4. But for several reasons, they are in this order. This 2 is a reason, and this 3 is also a reason. This 2 is now satisfied, whatever we put in here. So 1, 2, and 6. 6 is here. This is 1 or 2. This is a 4. We're still in 1, 2, and 6, and 6 can only be here. We need a 6 somewhere on this row. It has to be here. This is 1 or 2. We need a 5 somewhere here. This is never over. So let's have a look at this. 5, 6, 9. So this is fulfilled. 6, 8, and 9. This is fulfilled. 1, 2, 5, 6, 7, 8, 9. This 7 is fulfilled. This 4 also. This 4 is fulfilled. This 2 is fulfilled. So this 5 is the last place we need to look. We will always see 7, 6, 7, 9. We must see those in ascending order. So this is a thermo, an ascending thermo. Well, 5 is not here. It won't be here. 5 is here. So this is ascending, so that has to be the 4. And this should just disambiguate the rest, I think. That's a 5. That's not a 2. That's not a 1. This is the 9. And finally, the 9. The 9s are disambiguated at the very end, which is quite funny. So you just have to be methodical to solve such a puzzle. But what I'm thinking is that it takes quite a lot of work, quite a lot of scanning, and 49 points look quite underrated for me. Well, that was a very good puzzle anyway. Thanks for watching this video, and see you soon on Sudokanar.